In the following part, I will show you the field distribution in optical waveguide. Consider an optical waveguide. We have the light wave go this way. We also have light wave go this way. For light wave along this direction, you can have the phase front like this. And for light wave goes along this direction, you can have phase front like this. And we use the solid line to represent the phase fronts or peaks. And the dashed line are phase front of dips. We first consider the smallest value of m, as m is 0. When m is 0, we will have the smallest value of phi. We call it phi 0 here. We also know that beta, which is the z component of the k vector, is defined as n1k times cosine phi, right? Since phi 0 is the smallest value of phi, we will have the largest value of beta, which is beta 0. So as m is 0, we have the smallest value of phi and the largest value of beta, which are phi 0 and beta 0 respectively. And we put all these phase front in the same figure shown here. You can find out the phase front for light wave along this direction and the phase front for light wave along this direction. Then we first consider the direction of the transverse. We first consider the transverse direction. Z direction is our propagation direction, and the SY is our transverse direction. Along the transverse direction, you can easily find out that at the interface, we always have the intersection formed by the peak phase front and the dip phase front. Okay, maybe I shall call the solid line is the positive phase front, and the dashed line we call it a negative phase front. And along the dielectric interface, we always have intersections formed by the positive phase front and the negative phase front. Okay, so the total value along the dielectric interface will be 0. So these zeros make the nodes, which means that they will always be 0 near the interface. So along the transverse direction, you will have 0 at both sides, but in the center, you will have the positive maxima, negative maxima, positive maxima, and the negative maxima. So you always have a peak in the center. So along the transverse direction, you will have standing wave. Standing wave means that the light wave, the energy of the light wave, it will be combined in the center, and no energy will be transmitted out from the core region. That is the situation along the transverse direction. How about the situation along the propagation direction? As I have said, if we consider the center line, you will find out the positive maxima, negative maxima, positive maxima and negative maxima. Okay, and for the next moment, this phase form will move to the positive direction. So let's move the phase form like this. Okay, as the phase form moves to the positive z direction, you still find the nodes at the interface, but you can see that the positive maxima will move to this position, and the negative maxima will move to this direction from this point to this point, and from this point to this point. This means that as time goes by, this wave will move to the positive z direction along the z. Okay, so along the z direction, we will have propagating wave. In summary, for guided mode along z direction, along the axis of the waveguide, we will have the propagating wave, but along the transverse direction, we will have standing wave to keep the energy in the center. Okay, that is the situation for m is 0. As for m is 1, we have a little bit larger phi 1, and we also can find out their corresponding value of beta 1. Okay, for larger phi 1, you can plot the corresponding phase form for light wave in this direction. As for light wave in this direction, you can also plot the phase form positive, negative, positive, negative. In the transverse direction, you can still find out the nodes here, but we also find out a node in the center. So along the transverse direction, you can plot the field distribution like this. We have two nodes at both sides and one node in the center. Okay. Along the z direction, you can also find out along this direction, you can find out I should plot this direction. Along this line, we have the positive maxima, negative maxima, and the positive maxima, and the negative maxima again, to form the wave distribution like this. And as I have said, at the next moment, this wave will move to the positive z direction. It will lose like this. Okay? So for m is 1, we still have the propagation wave along the propagating axis. And in the transverse direction, we will have a standing wave. But compared with m is 0, we have one more peaks here. For m is 1, we have two peaks. For m is 0, we have one peaks. Okay? So for this case, for m is 1, we have two peaks. For m is 0, we have one peaks. So if you want to plot the field distribution of this guiding mode along the transverse direction, for m is 0, you can plot it like this. You have one peak. For m is 1, you are gonna have two peaks. So clearly for m is 2, you will have 3 peaks. And they will lose like this. Okay? Besides, m0 is the largest value of beta. As m is 0, we will have the largest value of beta 0. For m is 1, we have beta 1. m is 2, we have beta 2. And we know that beta 0 is larger than beta 1 and will be larger than beta 2. This is the field distribution for the guided mode in uphill waveguide. And clearly, if n is 5, you will have 6 peaks. Okay? In the following slide, I show you the field distribution along the transverse direction for m is 0 and m is 1. You can see for m is 0, you have 1 peak along the transverse direction. For m is 1, you always have 2 peaks along the transverse direction. So that are the field distributions for the guided modes.